In this short video, I want to show a new feature of NeuroDesk and give a little insight behind the scenes of this new feature. So for the people who don't know NeuroDesk yet, it's a reproducible and scalable analysis environment for neuroimaging. We package neuroscientific software in containers and make it available on every operating system out there, and also high-performance computing systems. We spend a lot of thought on how to make this as easy as possible for our users and also well integrated into their workflows. Our goal is to lower the barrier for reproducible neuroscience. And although NeuroDesk is still a young project, we already have users outside of Australia, which is great. But this led to a few problems. Our Singularity containers are currently stored in Australia Swift storage. So Australia Nectar is hosted in Melbourne, and there we have a storage bucket that I just show here. And from there, we pull our Singularity images. The problem is that this worked really well for Australian users, but it didn't work very well for users in the US or in Europe because they saw very slow download speeds. And also a problem that we realized recently is that Nectar Swift doesn't always work, and sometimes it has some hiccups. So we recently had this, and our images didn't download anymore, and they just stalled the downloads. So that was quite frustrating, and users flagged this as bugs. So we tried to come up with a robust and sustainable solution to this problem. And potentially this solution is also useful for other people. So that's why I thought I'd quickly show what we did. We thought about the standard solution to this problem. So setting up a load balancer or using a commercial content delivery network. But both solutions didn't really work for us. They would either involve more maintenance on the load balancer side or high costs for this content delivery network. After testing a few things, we settled for an interesting setup. We use multiple storage buckets distributed over Australia, Europe, and the US, and even different clouds. So in Australia, we use the Nectar cloud, and in Europe and the US, we use the Oracle cloud. So this is the bucket on the US East Zone in the Oracle cloud, and then we mirror the same bucket over to Zurich, so we have something in Europe. And then we do the load balancing on the client side. So on the client, so this is now NeuroDesk, we use a tool called ARIA2. And this is basically curl on speed. So you can give it multiple URLs and it will download from multiple locations at the same time. And with this, we get basically redundancy and really high speed wherever we are in the world. And we don't have to worry about pulling from the right server and identifying the right server. So let me show this in action. So let's download a toolkit here. So we use Slicer and just increase that. And here we see that it's downloading one item. And we're currently pulling with about 60 to 100 megabyte a second. And you see that we just pulled a 500 megabyte container in a few seconds, which is really cool. And then the application gets set up, integrated in the environment, and then the application starts for the user. So it's super easy for the user to set up. And that was always to goal, to make it as easy as possible so users can just get the software they need, get their work done, and do it in a reproducible fashion because they know exactly which version they used, and we preserve all these containers. So let me now show you this robustness feature that we wanted. So let's say our Australian server is down. So what I will do is I will just delete one of the packages. So here is ANS version 2.3.4 built in October. And this is the version we currently use of ANS. So I will now delete that from our Australian mirror. And this now simulates that our Australian mirror has a problem. So let's see what happens when we now try to download this. So we go to ANS, and there's something very cool happening. ARIA2 realizes that one of the sources is down, and that's pretty much it. It realizes there are two more sources, and it just pulls from these two other sources. And of course, now the download speed is not as fast because it has to pull from the US and Europe to Australia, but we still see 18 megabyte a second, which is pretty decent download speed. So this is pretty much what we built. I hope this is useful for others. Let me know in the comments if you had a similar problem to this and this is useful for you, or if you found an even better solution to this problem. And now it's downloaded, it's setting it up, and then that's it. And now we can use ends on our virtual environment. Good. Thank you very much. Have a good rest of your day. Bye-bye.